all circle theorem rules explained, how do we find them, and solving every single question, so we know how everything goes. Okay, and by the end you may be tired using all the rules also, but come on, it's okay. We got like how many questions? Like a few 29 questions to go. It's okay, we can complete all of them. Okay, soon enough. Okay, let's drop. EC is a diameter. Okay, this diameter meaning we can use our first rule that we know, that when there's a diameter, the short is the right triangle. Okay, because why would they give us? Okay, so this is a right triangle. We can see we can complete for z, which is 90 minus 59, which is 31. Excuse my group chat, please. Okay, next we can find x. Why? Because x is made by EB, and so is angle 62 made by EB, and we know the double angle thingy, angle at circumference is doubled when at center. Okay, they face the same relative direction. Okay, so we can use this fact for ourselves. So this is 62 times 2 is equals to 124, like so. Next is solving for t. How do we solve for t? Well, we can use a cyclic quadrilateral. How is it made? It is made by EABC. If I outline it such, EABC. Okay, let me just put down the stroke a little for further. EABC. Okay, you can use this to our advantage. Okay, t and opposite to it is 80, so we can use this to our help. This is a isosceles because of radii. This is 62. 80 plus 62 is something. 180 minus 80 minus 62 is equal to 38, which is our answer. Okay, if I'm talking too fast because I don't know how much time I have. Okay, sorry. Next, using this, we can solve for y. Okay, so this is 360 minus 38 minus 80 minus 62 minus 62 again, which gives us our final answer of 118. This is also given if we use the cyclic quadrilateral trick again and see opposite of 62 is 9 is y, and so we can do 180 minus 62 is equal to y, and there we have it, all of our answers. X was 124, t was 38, and y was 118. Okay, moving on. If we are this slow, then we will never finish it. Circle radius of the circle is 6, so it's 10. Sorry, yeah. So we immediately draw radius. Okay, to all the points, like so. We know this will use the second last rule in my notes. Yeah, which is that this is a 90 degree. This is always a perpendicular bisector. This is the midpoint as midpoint always, and is told to us, and we need to calculate PQ, and PQ, it is the double length of this. Now we can, how do we do this? We just find XQ or PX and then double it to find PQ. So PX will be 8 because this it is, and then double it to get 16, and 16 is our final answer. Boom. Some some trigonometry, some angle properties, and some circle theorem will get you there. Okay, next is find the, what are we given? Straight line dt is a tangent to the circle at t. Okay, we know tangents. Dt is a tangent, so this will be a 90 because this is a radius, this is a tangent, so this is blah blah blah. Okay, next we need to find AOT. ATO. How do you do this? Well, this is a isosceles. It is made by radius and is last, so this is 32, and boom, we get the answer. TDO. How do you do TDO? TDO. So we know this will likely want this angle, and to have this to get this angle, okay, like right over here, we complete this triangle. No, we double this or either find this and then 180 minus this. Okay, so angle at center thingy, this is like this, and doubling it we get 64, like so. Next we do 180, 90 minus 64, okay, because that's faster. This is 26 as our answer, 26. And before doing anything, you mark your angles, okay, then you do it. That makes it easier, you know. Next is ABT, and this can be done by seeing ABT, angle B is made by 80, and so is angle O by 80. So you know we need to find this big angle by blue, okay, represented by blue. So this is 60, no, this is 180 minus 64, which is 116 over here, and then we divide by 2. 116 over 2 is equals to 58, and that is our answer, 58. Nice. Next to a scary question, but don't worry, be not afraid. Next, first is straight lines, parallel. Okay, this parallel line, meaning we will use it. Okay, every information in the question is given so that you can solve it. Okay, that is the great thing about Cambridge. Okay, first find BAE. BAE. Well, what are we are not given this, but we know, no, APE is a straight line, and the center is P. If P is a center and this is a straight line, okay, well, if we identify this is 90 degrees, why? Not because we labeled it, because it is, because it is a 90. This AE is a diameter, okay, they haven't given to us, but sometimes we got to do our own hard work and identify them. So this is 90 minus 36, which is equals to 54, and that is our first answer. Then it is EBD. What is EBD? EBD is this 54. I like saying EBD. For this we use angle properties. This is the same as this. If we make a drop down like so, we see this is like a parallel thingy, okay, and we can use corresponding angles to solve this. This will be the final answer, 36, okay, because if we just extend this over here, and if we extend this out here and over down here, you see, and this setup is the same as this setup over here, and that's why we can use 36 over here. Then we find BDC. BDC is this. Now this is angle at circumference thingy. These two face the same general direction or are made by both BC. So we can do 122 over 2 is equal to 61, and that is our answer, 61. Done. Next, our final answer is DBQ. D, B, and Q. We need to find this angle, okay, and I will show you how. By how do we do it is we know that this DBQ angle will be the same as this. Now don't worry, this is correct, okay, there's no magic going on, this is correct, okay. So we do this, and we see that this is a quadrilateral, so we need to find this angle and then add it with this and then divide by 2 to get the right answer. Okay, no, I'm wrong. Okay, so this is how you actually do it, okay. Sorry, okay. We see that this is a 90 over here, and this is a straight line. What is the remaining angle? This is also a 90. Now this is 36, this remaining, and this we can find this, okay. This is isosceles triangle. So this is 180 minus 122 divided by 180 minus 122 divided by 2 is 29. So we know this is 90 minus 29 minus 36 is equals to our angle. 90 minus 29 minus 36 is equals to 25, which is our answer, 25. So to recap, okay, this angle, why do we do it? Because this is a 90. We know this angle, we know we find this angle, and so the remaining should should be such that when we add all three angles it should be 90. Okay, I hope you understand this, and let's keep moving on. Okay, find ATB. So remember, this is 90, this is 90. The center angles add up. Why? Because this is a quadrilateral. 360 minus 90 minus 90 is equals to 180, and 180 is 132 plus this angle. Okay, 180 minus 132 is equals to 48. Okay, be careful of what you are typing in your calculator. Okay, ATB. Okay, BDA. What is BDA? BDA is this angle. This is same facing angle. 132 over 2 is equal to 66, and that is our answer. Next is BDC. It is this tiny angle. Now, how do you find this teeny tiny angle? We can by knowing some things about a circle. AOC is a straight line, and when it is a straight line, what do we know about it? Yes, it is a diameter, and that this entire angle sum up to 90 degrees. So 90 minus 66 is equals to 24, and so this little angle is 24. Nice, good, done. And then we need to find OBD. Yes, OBD. How do we do OBD? Well, we can by not using the wrong trick earlier, we use the correct trick earlier, and this is by, and some people might think they can just use that angle, ASC. No, this is not ASC. So you need to do a little bit of hard work, but you will find it eventually. Okay, we know all angles of this. Why? Because we can just find this easily. 180 minus 24 minus 59 is equal to 97, and so this is 97. This angle, how do you find this angle? You can find this reflex angle. You subtract 180 and we just find the remaining of this angle. So this is 180 minus 132 is equal to 48. Then we complete the triangle. 180 minus 48 minus 97 is equal to 35. Nice, and that is our answer, 35. Okay, a little bit of hard work, but once you get in, you will get used to doing hard work for like 1 mark. Sorry about that. What special type of triangle is triangle ABT? Now remember, ABT, these two sides are same, so this is isosceles triangle. Okay, don't mind my spelling. Work out AOB, meaning work out this angle. How do we do this? This entire angle is 90, so what should the remaining be? Yes, 90 minus 64 is equals to 26. So this is 26. Okay, alternatively, you can find this angle and then subtract it by 180, but it's the same thing. Okay, this is 26. This will also be 26. Why? Because this is a isosceles. Why? Because both are radius. And 180 minus 26 is equals to 128, and that is our final answer. Another method would be this. This is 180 minus 64. This is 52 180 minus 52 is equals to 128, and that is our final answer. Same. Calculate 80. What are we given? The radius is 6. Done. That's all we needed to know. So this is a t. We know this is a tangent, and this will be 6. This entire length will be 10. We use some Pythagoras. We find 8, and that is our final answer. Very easy, very quick. Okay. Next is this fun question. Okay, every question is not fun, but come on. X is the same opposite, same double at center. 186 divided by 2, 68. First we find this 68. Next we find angle T. Okay, T, that can be done quickly. This is 90, this is 90, so this is 180 minus 186 is equals to 44, and 44 is our answer. Write the correct answer in the correct answer space. Okay, do not get worried about that. Next is this. Okay, we can use some angle properties to help us out. If we extend this like so, we can find y here. If we extend this like so, we can find y here. Okay, I do not know why I did that, sorry, but we can find y here because it is the same setup. So this is 136 minus 180 minus 136 is equals to 44, the same answer. Okay, this is not a coincidence, trust me. Okay, next is z. How do we find z? Well, we know that we have a method, acyclic quadrilateral. Okay, acyclic quadrilateral ABCD. So we can use that to our help. This is 180 minus 68, which is 112, and that is our final answer. Moving on, let's do this question. Okay, find the value of x. Very easy. Oh my god. How is this made out of? X is made out of AC and U. Okay, this is not that easy. No. This is easy. Why? Because AOD is a diameter. And so this is 90, and we can complete this by 90 minus 43 is equals to 47. See, math, it does not need to be hard. It just needs to be annoying to do it. This is 90 because tangent 90 minus 68, sorry, this is 22. Okay, 22. Next, we can find the value of y by this, and this is very sneaky. This cat ear, if you see, this cat ear is made by BA, and so is angle 68. So that's how we can do this. So this is 68 over to 34. Y is 34. Okay, it's like very sneaky, but sometimes you just have to see sneaky things. Okay, like move this towards the center. See, does that work? Because you suspect O being made out of one of these, and so you might bring this to the center, to the circumference to find any angles, and sure you do, which is y, and that's how you get the answer. And the value of t. How do you find the value of t? Well, this is done by completing this. 180 minus 43 minus 68 is equals to 69. Nice. 69, nice. And you can complete this. It's 180 minus 69. Nice. 30 minus 34, which is 77. And that is our all complete. 34 and 77. Nice. Next, question number 10. Okay, halfway there, approximately. PQ, RST, and TR point 76 circumference, blah blah blah. PQ. Okay, this is the isosceles. Okay, find PTS. PTS. Need to find this. And this, you may think this is like, oh, 180 times 5 minus 2, which is 3, divided by 5, 180. No, this is not that. This is not perfect. Okay, this is not a perfect polygon. Show all of your working. Ooh. Okay, so how do we do this? Well, this is a isosceles. We may as well find the remaining angles. 180 minus 118, this is 62, and divided by 2, this is 31. Let's find the remaining angle of this. Okay, why? Because we see a cyclic quadrilateral. Okay, and we know opposite angles add up, and we need to find the remaining angle of this to find the angle this. So this is 99 minus 31 is equal to 68. 180 minus 68 is equal to 112, and that is our final answer, 112. A bit tricky, but you will get used to it. These hard workings for like oh thank god, this is like 2 marks. Okay, temperature is generous at times, Find ECD. So how do you find ECD? No, this is not the angle at say double circumference thingy. We can find this by doing a lot of hard work. Firstly, we make this. We know this will be a isosceles, and so will this be isosceles. Now this is 60, and this is also isosceles, so this will be 60. This is a equilateral triangle. Okay, we find that AE is equal to EC is equal to DC is equal to CB. We know many things about this. And we need to find ECD. This is a third in this. Next, how do we find the remaining angles? Well, we know that. Okay, let's do some drawing. Okay, if we make radiuses. Now these are 4 triangles, and these all 4 are same. Okay, why? Radius, all of them are radiuses. So this will be 4x, this here. So this is 360 minus 60, which is 300. 300 over 4 is 75. So every one of these is 75. Now these two are this is a isosceles, so we find one of these angles over here, which is 180 minus 75 is 105, divide by 2, which is 105 over 2. But what do we do? This is the same angle as this. Okay, and if we add up this will be 105 plus 105 over 2 over 2. This over 2 cancels, so this ultimately is 105. Okay, watch it again. Okay, you may not see this trick anywhere again, probably. This is equal. We know this will be half of 105, which is 52.5. This is also 52.5. But then we look at the bigger picture. We look at this. This is also a isosceles. This angle at the top will be 180 minus this. 180 minus 52.5 minus 52.5. So this gives us one of these angles being 75, and so this is also 75. This is no coincidence. This is a coincidence, but it is not, because you can just copy it over here. Okay, and that's how you get this. Okay, isosceles, or you use this isosceles triangle to find this angle, then you double it, and give it to the next person. Who this next person is two people, which make a isosceles triangle, and then we find the remaining angle, and then we find the thingy. Length of the minor arc AB. This is like child's play. This is paper 1. You can do this without a calculator. Okay, I'm just doing it with a calculator too. This video to be going on. Okay, skip this question. Okay, screw this. Everyone knows mensuration. Okay, find answer x. How is x made? Well, let's read the question first. AC is a diameter, meaning this surely is a 90 degrees, and so is this is 90 degrees. Okay, we found one. Tangent AB is produced at T. Okay, it produces T. Find x. Okay, we are given some angle 62, 70. This 62 will help us. Why? Because no. First, let's see what we are working with. Yeah, this will be a 90 degrees because this is a tangent. This tangent to the circle at C, meaning if you make this big tangent, okay, and if we extend AB, we get a 90 degrees tangent T. So you find the angle of x by doing 90 minus 62 is equals to 28. See, you read the question, you can do the question. 28. People don't read the question. Okay. Y, angle of y. Y. How do we find this? Well, first of all, let's find the angle. I feel like finding the angle. Well, you cannot feel like finding any angle. You have to find all of the angles. Yeah, we can find this angle because let's look outside. Let's look at the question again. E lie on the circle. Okay. Yeah, we can identify a few things. That this is a cyclic quadrilateral. Okay, now we know y and z add up to 70. This does not help us. So let's keep looking. We can find this angle. So this is 90 minus 62 is equals to 28. How does this angle help us in finding our solution? Well, you cannot make any other angles without, guidance or anything. We do find another cyclic quadrilateral. Like so. 70 is opposite to this. Yeah, okay, we can find 70. Thank God. Okay, so this is 180 minus 62 minus 70. So this is angle 48. Nice. See, we just look around. Wow. And oh no. Okay, nothing. And we can find the angle of y by knowing this cyclic quadrilateral. Opposite angles add up to 180. So this is 180 minus 70 minus 48, which is 62. The answer is 62. Yay. 62. See, that's how easy it is. Two quadrilateral cyclic quadrilaterals. Okay, there's nothing that we needed with O at all. Okay, well, yeah, it literally did nothing. Find CPR. Okay, CPR. No jokes this time. CPR. Okay, and let's go. Okay, now finally we use that angles in the same segment are the same. angles in the same sector are same. P, R, P, B and C lie on the same sector or C. If we go around like so, you can see these two cat ear shapes. These two cat ear shapes or PC and or BC are same. Okay, so we can say this is 40. Not only we can say it, we need to say it. CQR. Next is C, Q and R. Now this is hard to do because of the diagram. Okay, this will be like HD, Ultra HD in the PDF, of course. And how do we do this? We look opposite to it, we cannot find nothing. What else information are we given? We are given AD and BC are diameters. So we can do some stuff with it. A and B are tangents. They make 90. This may come to our help. Okay, and let's find out more about this triangle. Okay, what is other parts? ABD. What is ABD? ABD, this is easy. This is just 50. 90 minus 40 is equals to 50. ABD is equals to 50. And ADB, this can be found by doing some, this is just completing the triangle, this large triangle. This is 40. Okay, no angle thingy going on. Okay, sorry. So we find these two and CQR, C, Q and R. We know that this will, yes. Okay, I finally see it. Okay, do you guys see it? No, this is not a Dora the Explorer. This is a cyclic quadrilateral. Yes, finally I found it. You just got to look around everywhere. What is opposite to this? I was looking at this. No, I should be looking vertices at the circumference opposite to it. Okay, that's how you do it. Vertices opposite to angle. That's how you're gonna find cyclic quadrilaterals. So this is 180 minus 40, which is 140, and that is a massive angle. So yes, it is 140. Oh, AD is a diameter, meaning C is 90. Okay, we might have something to do with this, like find ECD. CED. DEC. Okay, let's just keep going. Okay, let's find. Oh no. Okay, nothing. CDA. I thought someone was home. CDA. And CDA, yes, I'm spamming it. This is like this. Yeah, we needed to use this 90. I knew it. Because this is 90 minus 33 is equal to 57. 57. Next, we need to find DEC. How do you find D, E, and C? Well, we can do this by solving for things in our triangle. Firstly, we can find how is this angle made. This angle is made by C and D. Is there any other angle made by C and D? Yes, angle A. And we just happen to find this big thing. With this, we know that angle A is the same as angle E, which is 33. Let's go. Things aren't impossible. It's just that you need to find how to make it possible. ABC, a good trio, but a bad trio in circle theorem. ABC, so we can use a cyclic quadrilateral. Why? Because I looked opposite to it. This is 57, and 57, how is it? This is by cyclic quadrilateral ABCD, and this is 180 minus 57, which is 1 2 3. ABC, ABCD, 1 2 3. Let's go. The reflex EOA. Ooh, EOA. Why did I put reflex? Because your reflex was this. No, the answer is, we can find this by doing some, I don't know. Yes, we get the angle at center and then 180 and then 368. So this is angle at center. We see at this angle is 140. Then we do 360 minus 140. It is greater than 88, 180, and this is 120, which is greater. It is a reflex angle, and so we find the answer correct. Next is question number 14. Find angle X. Oh God. No worries, don't be. This can be found by some double angle shenanigans. Why? Because we know angle X is made by dB, and so is angle Z made by dB, and we know X is 2Z, so it would be better off finding angle Z first and then angle X. Yeah, I know this is a weird thinking, but this is the thinking required, I guess. How do we find angle Z? Well, we know angle Z is made by dB. What other angle is made by dB? Yes, angle 34, angle A. So we see that angle A and angle E lie on the same circumference in the same arc, and so we can say this is 34, and 2 times 34 is 68, which is our answer. I know this is like multiple rules at once overlapping, but sometimes you just got to do this. Next is, how do you find the angle Y? Well, we do this by using a cyclic quadrilateral. Why? Because I looked opposite to it and knew this is a cyclic quadrilateral, and done. 180 minus 34, 146. Find the angle of T. How do we find the angle T? Well, how is it made? It is made like so. If you look in front of it, angle T is made by DE, and so is angle O. So we know this is 2T, and the remaining of this on the circle is 2T. 180 minus 68 is 112, and then we can just half it to get 112 divided by 2 is equal to 56. See, this is a compound and a circle theorem. Everyone loves compound stuff, especially in Cambridge mathematics. Question number 15. We have a statement question. I hate them. With a geometrical reasoning. Why is PTQ the same as PSQ? They gave us the answer, but we have to explain it. Well, the answer is because angles in same sector, angles on same arc are equals. Next, PSQ. Find PQT. P, Q and T. So PQT, how do we find this angle? 1. What do we know about the circle? QT is a diameter. So this QT out here, P is 90. And we can find the angle PQT. 180, 90 minus 35 is equals to 55. Nice. SPQ, S, P and Q. So we need to find this tiny area. Yeah. SPQ. How do you find this? Well, we can do a cyclic, but we cannot really do a cyclic right now. So let's use this thingy. We know we can complete for this angle, then have this, and then complete for this angle. Yeah. Why do we know this? Because we just do 125. You may not see it, but I do see it. We know for P, we need these two angles to be done because this is on this triangle. Okay. And for this angle to be used, we need to complete it first. Well, this is on this triangle like so, and we know for this to be complete we need to find this, and for this we know vertically opposite this will be, so this is 180 minus 125 minus 35 is equal to 20, and this is 180 minus 35 minus 20 minus 55, 70. Nice. S R Q. I'm going to say it. 110. Why? Because of a cyclic quadrilateral. We gave up finding any thingy, so our last option is looking to the opposite to it, and we find a angle opposite to it, and so we do cyclic quadrilateral. Okay, you do have to make sure this is a cyclic quadrilateral after all. Okay, so you cannot just do shoe opposite I find the angle. No, you need to see that is it a cyclic, the entire shape, is it made by a cyclic quadrilateral. Okay, about halfway, approximately halfway, 5 questions, many more to go. Calculate BCA, BC and A. So we find this is a 90 degrees because this is a diameter. You're not given diameter, but this is a diameter. 52. ATB, and this is found by some difficult stuff. Well, one, we know that this is 90 like so. This is this is a isosceles, and so this is 38. This is as 90. The remaining angle would be 90 minus 38, which is 52. I already have it calculated somehow. Yeah, and this is a isosceles because AT and BT will be same. So this is 180 minus 52 minus 52 is equal to 76, and that is our answer. Okay, we got to draw some things ourselves sometimes. Okay, if we can't have it, we may draw it ourselves. Okay, and this applies to everything. Yes, find x. Immediately we know this is angle at center. 53 times 2, 106. answer y. How do you do this? Well, this is the case I teach alongside angle at center where if we have this reflex case, we need to be wary of this reflex case also. So this is 360 minus 106. It is 254 divided by 2. What do we get? 127. 127. Find the angle z. Well, this is the same. 180 minus 62 is 118 divided by 2. It is 59, and that is our answer. Find the angle T. To find the angle T, we do some stuff like we know that it is made by a few things. Tangents, this stuff, that stuff. We can draw this like so. Let's just remove this reflex. Next, we know this is 62, and so we know this is 180 minus 62. This is 118. This angle. This is a isosceles. So this angle would be the half of 180 minus 118. 180 minus 118 divided by 2 is 31, and that is our answer. 31. Okay, that's how we get it. Okay. You sometimes do not get questions where you need to draw stuff, but you need to get used to drawing stuff in diagrams and there is not given any. Okay, and that is my main point. Find the angle x. Parallel. You may use this parallel, and parallel we might need to yes, we might need to for angle. No, we can find x first. We see opposite to it is 127. Why? This is a cyclic, and yes, we can do this. 180 minus 127 is 53. Nice. Next, for the angle z, how do we do this? Well, we can do this by looking at here. This is a z shape. No, this is a z setup. So we can do corresponding angles. So this is 40 minus 62. This is 22. Sorry, 62 minus 44. 62 minus 40. Happy Ramadan, I guess. Next, we need to find the last angle y. Let's look at it carefully. 53, like so. How is this made? This is made by BC. What other angle is made by BC? Yes, angle E. So we can do for E. Why? Because they lie on the same thingy, same arc, and so our thingy is used up. This sometimes they give you angles to throw you off. No, nothing. Sorry. Yeah, find EAD. EADO, all the way out there. Nice. And we can do some angle at center shenanigans. How? Why? Because ED is made by E is made by ED, and so is O, and so we can put it down. Okay, another explanation is this. If you draw a new angle, say F, if we do, you can copy this over here, and then this faces the same way like so, and then boom, this is how we can do it. Okay, I should put these, tricks, recompile these tricks sometimes, but no, I want a watch time, so you got to watch the whole video to only find this to find these miraculous tricks I find by myself and teach it to you, because I found it while working on the fly. Yes. EAF. Okay, I may find more tricks. EAF. Ooh, this calls for, yes, this calls for AST. Finally, I know. Let's find other angle. Yeah, AST. How does this work? If we have a triangle over here and there is a tangent on one side, we know this will be the same as this. And no, it is not a 90. Ooh. EAF. This is this. We do use ASC in some shape or form, in some way, but not in like this way. Yes, no, sorry. This is a 90. Yeah, this is a 90. This is a tangent. 90 minus 69, which is 21. Like so. Boom. Yeah. You see, this is like so obvious. You just cannot find it. Even I cannot, but after looking, rejudging, done. BEA. BEA is this. We know one angle of here. How is BEA made? BEA made is by BA, and so is angle D. So we can bring it up here. Now, why do we need to bring it up here? What are we doing all the way up there? Well, we are doing something, and that something is hoping we can use AST, because we sure can. Why? We cannot. Yeah. This is 90. I know this. This is 90. I do not know this angle. And that's the issue. We can use, what do we call? Cyclic? No. See, this is how thinking works. We can find this remaining angle. What will that do? This remaining angle is made by AE, and AE makes no other angles. This is made by BA, and BAB, EAF, BEA. Yeah. See? Like so. We cannot do any. Oh my god. Okay, I found it. Yes. This shenanigans. Okay. Now, we do not know this complete angle, but we do know this is radii. This is isosceles, and so this must be the same. This, because this is 69. Nice. This will be also add up to 69. So this is 69 minus 12, which is 57, and done. Okay. See, let's think together. BCD. What is BCD? BCD is this. We can find it by using, cyclic quadrilateral, and we can find this remaining angle. Now this is 57. We know this is 57. We know this copies over to 57 over here. Then we use angle segment alternate segment theorem to find that this is also 57. Nice. And so this entire thing adds up to 180, so we do 180 minus 57 minus 69 minus 21, which is angle 33. I know, a sudden energy boost, but once you make all assumptions, the one last assumption, and boom, here you go, you are off. 180 minus 33, it is 147. That is big. This is big, and our answer is perfect for 2 marks. Yes, all this effort for identifying AST on also one of the I think most stupid rule and hard rule to do. I think I just had like trust me bro on that one on the video explaining it. But yes, this is like a trust me bro. I do not know how to prove it. One day I will. Someday. Find the angle x. Angle x is made by like so. And what other things do we know? This is a circumference BE, and so this is a 90 degrees. We know, right off the bat we find a z because of parallels. Okay, we find the z, and we know this is 53. This will be 53 also. 53, it is angle z. 53, and t is 90 minus 53, which is 37. Angle x is then double this. We double this, we get 53 times 2 is equals to 106. Nice. See, you just need to think somewhere else for a while to find this. And angle y is this reflex is 2y, and so this will be like so. 360 minus 106 is 254. 254 divided by 2 is 127, and that is our answer, 127, like so. Nice, really good question. Okay, and we are in the home run. Okay, I know it. 1 hour of pure video salute. How do you do this? ABD, we get 69. A, B, and D. A, B, D. Yeah, okay, immediately I found it. Why? Because ABD is made by AD. What other angle is made by AD? 34. So we get this. Because why? Because they are on the same circumference, same arc. Sorry. So ABD is 37. AOD. What is AOD? AOD is multiplied by 2. 37 times 2 is equal to 74. Nice. And this is 74. Okay. DAB. DAB. What is DAB? That's a good question. It's a dabbing good question. We can do some shenanigans, aka a cyclic quadrilateral. I looked to the opposite. I saw I can vanish this line out of my will and see, out of my will and out of my ignorance, ability to ignore things like circle theorem rules, and we know this is 180 minus 69 minus 34, which is 77, and our answer is, and our question is done. Okay, let's remove this. Nice. Find the angle of x. Right off the bat we find a this two isosceles. Damn. Okay, tangents, thus another isosceles. Wow. Okay, so we can find the angle of y then we can find angle BOC, then we can find the angle of x, and boom, everything comes together like a family. 62. 180 minus 62 minus 62 is equals to 56. This is angle of y, 56. Then we do 180 minus 56, which is 124. 124, this is the isosceles, so what do? We do 180 minus 124 divided by 2, this is 28, and that is our final answer. Nice. You know, it's fun once you know how to do it, but it's not fun when you don't know how to do it, you know. Find the angle of x. This is a isosceles, okay, because this is my radius, so this is 180 minus 48 divided by 2, 66. I promise you, I have never seen these questions before. Okay, there are people who are like, I've done these topicals, I've done all of these topicals before. You suggest them new topicals, I've done them also. So those psychopaths want more questions. Like, bro, stop. Angle y is double angle at center. Okay, 54 times 2, 108. Now yes, to be good at maths, you need to do a lot of questions, but what is the point if you are still bad at maths? You still need more questions to solidify your understanding. You sometimes got to believe in yourself, and so you don't need like billions of questions. Okay, find the angle of z. We can see, to find angle z, we need to make a quadrilateral angle. Yes, I looked opposite to it. So done. 180 minus 54 is 126, and that is our angle. Answer done. Okay, I am showing these past papers. Okay, this is the cool, the best thing about a red spot. I love red spot. Okay, it is, they have dividers. Okay, it makes it look like you can just cut a question and hand it out to people, you know. Find the value of x. I hate this. Oh my god, this is 4, this is 6, this is x. We know this is a 90 degrees, this is something, this is something. We know 10 plus x squared is equals to 4 plus x squared, 4 plus x quantity squared, and we know there is going to be omission of a negative somewhere, or omission of a low angle. Okay, I will tell you this. This is 10. No, I cannot guarantee it. Okay, so this is 10 plus this leg is equal to this some leg. Okay, so this is 10 plus x squared is equal to 16 plus 8x plus x squared. Okay, no omission. Okay, omission by only one angle. Okay, this is 10 minus 16. What? What? Oh no, 10 squared. Okay, yeah, see, this is how you make mistakes. You forget one thing and you make it all. Okay, this is 10 squared. This 4 plus 6 is equal to 10. So 10 squared minus x squared is equal to this quantity 4 plus x. This is 10. 100 plus x squared is equal to 16 plus 8x plus x squared. X squared is cancelled on both sides. You move 16 over there. 100 minus 16 is equal to 84 is equal to 8x divided by 2. 84 divided by 8, sorry, and x is 10.5 as the answer. Very weird, I know. 25. Find the value of x. Okay, this is a little weird, but we can do this. We are given tangents. AB is tangent to this circle. We know this is 2x. Okay, immediately. And you can find the remaining. This is 90 minus 36 is equal to 54 divided by 2 is equal to 27, and that is our answer. Okay. Final few questions. Where are the home run? Okay, this is the second time I'm seeing this. Find DEG, yes, DEG. We can, this is so obvious, this is 75. 75 is made by DG, and so is 75 made by DG. Find the angle dog, not, yeah, DOG. So this is double 75 times 2, 150, yeah, 150. DBC. What is DB and C? Ooh. Nah. No, we cannot use AST. This is like so annoying, you know. We can do this many ways. I'll just tell you the quick one. Okay. A reflex. Find the reflex. This is 360 minus 150 is equals to 210. 210 divided by 2 is 105. Okay. 210, 105, and then we fill this. This is 180 minus 105 minus 48, which is the remaining angle 27, and that is the final answer, 27. What is my other method that I supposedly propose? Is that we bisect this angle, we make it this, and we find this, and then we do 90. It gives us the same answer, but come on, you know. Find ADB, AD and B, ADB, and this is the same. 70 is made by BA, so half it we get 35. Nice. Immediately 35. Wow. Angle BCD. Sorry. There is points on circle. Okay, there is points on the circle. I give up, so meaning I look across it, we find A. Can you find this remaining? Yes, you can. This is a isosceles. So this is 180 minus 70, which is 110 divided by 2, which is 55, and we find the total angle. 180 minus 25 minus 55 is equals to 100, and boom. Oh, second last. Find COB. COB. You know, you have reached your limit when you call angles by this. Ooh, finding expression in terms of x for each of the following and in simplest form. You know, this will undergo angle at center. So this is 2x. A or B, OAB. This is 90. Yeah, 90 minus 2x. Boom. Then CBO. CBO, how do you find this? This is the isosceles. So this is 180 minus 2x all over 2. It is 90 minus x. Yeah, trust me on that one. Nah, I'm the sovereign of algebra on Discord. You can't trust me on that one. So this is 180 minus this, and then divide by 2. We find these two little angles, and we find CBO, like so. Final, and this is so out of course. This is like the out of ordinary. This is explained in the first page of the circle theorem in my notes. Okay, this is like so rare. This has never been asked before. Other than this question, I kid you not how much I hate Cambridge for this. So this is a tangent because it's at one point. I hope so. And this is a sector. how generous of them to find radius, and that is every single question in this file about circle properties. I hope you guys learned everything about circle properties. Like, subscribe, share, and happy Ramadan.